Hi everybody, welcome back for another week summary. So this week we've been talking about chapter 4 and it's mainly looking at cells. So two big concepts with cells. Number one is knowing the cell parts. Okay, so what is inside the cell, difference between prokaryotes, eukaryotes. Of course, prokaryotic cells don't have organelles, eukaryotic cells do. And then knowing all the different structures. So we had the matching, so make sure you go through that and you know what all the structures and the organelles do for the cell, and then what would happen or be able to identify the organelle that's messed up under different situations. So again, if somebody's really lethargic and they have low ATP levels, what does that indicate isn't working properly? So make sure you're familiar with that. Things that all cells have: ribosomes, cell membrane, they have the cytoplasm, and they have ribosomes to make those proteins in DNA. So again, DNA, ribosomes to make proteins, cytoplasm, in the membrane controlling what's coming in and out. Right, then the other big thing is the transport. So it's really important that you know the difference between regular diffusion, so going from a high to low concentration, facilitated diffusion, also high to low, but now we need a transport protein. It's something that can't cross, so it's charged, it's too big, something, and so it needs a transport protein to get into the cell. And then active, this is the one that needs some energy to get everything moving because it's going against the gradient. So from a low amount into a high amount. So especially in our stomach, as we're eating, we want to absorb all the nutrients. So all the amino acids, all the monosaccharides, we want to absorb them all. So we would need to use some active transport. Even once we have a lot of glucose in our cells, we still want to suck up all the glucose from our stomach. So we may have to actively transport some of that glucose or some of those amino acids into our cells. As well as just some facilitated diffusion. If there's a lot, in the stomach and not in the cell, it could just facilitate its way across by regular diffusion. And then the other big one is osmosis. So I set up a little demonstration here to talk about osmosis, and hopefully the video shows everything okay. So what I have, just first of all, to kind of start us out, I have two potatoes here. So my first potato is pretty firm at this point. I mean, I've had them for a little bit, but it's pretty firm. If I try to bend it, it doesn't really do anything. It's pretty nicely plump and full. It's not really wilted anywhere. Whereas this other potato is pretty wilted. Try to zoom in. You can see the divots on it, but also if I bend, it's really squishy because, again, it started to lose some water. Okay, so if you have potatoes like this, we don't eat a lot of potatoes, so whenever I buy a bag, it's very often they start looking like this and start getting all flimsy, which isn't very tasty once you start to make French fries or whatever you may do with them. So a little trick that you can do is you can use the power of osmosis to take this potato and make it more like this potato. So what I've done is I've set up, let me just switch us here for a sec. So I've set up 3 containers that you can see here. So the first one is in a hypotonic environment. This was cut from my wilted potato. So I placed one in a hypotonic environment. So that's just pure water that's in there with that potato. The isotonic, there's no water that's in there. It's just the regular potato from where I cut it. And then there's also hypertonic, just to show you kind of what happens with it. I added a bunch of salt to that water. So what I want to show you is what happened then. All right, so if we take again the isotonic, and again, this is what happens in grocery stores as things kind of set around. Again, this one's very pliable. I can bend it and move it. You can just kind of go in there a little bit. You can see the edges around the outside. So again, it's not very full of water. And this is called flaccid, is what your book refers to it as. So the central vacuole in there is starting to lose some water. The membrane's not pushed out against the cell wall. So again, kind of wilted-like. All right, then we'll save hypo for last. In my hypertonic solution, the one with the extra salt that I added, Again, it's very similar, but to get extremely bendable, I can move it and twist it all around because, again, what would happen is in the hypertonic water with all that salt, okay, when cells are in a hypertonic solution, think real quick, what happens to the movement of water? Maybe even pause the video and think about it. If a cell is in a hypertonic environment, what happens to it? All right, well, water goes from a hypo, where there's less solute, to a hypertonic. Okay, so we have some solutes inside the cells, like amino acids and DNA and all kinds of things are inside of the cell. Okay, but I dumped a lot of salt in this other solution with the water. So there's a lot of salt, a lot of solutes outside. So water is going to come out of the cells here in my potato, and it makes it even more wilted, more pliable, more bendable because it's losing water. All right, now my hypotonic. So again, if you had a wilted potato and you wanted to fix some nice crispy French fries or something, what you could do is take the potato, just cut it in half, and then stick it in pure water. Because what you can see is if I try to bend this, and I promise I'm giving it equal force, I'm not manipulating you, but if I try to bend it, it's not. It's very hard. At this point, it's crisp. So again, I can bend it about to there. But just feeling the texture, again, it's not very pliable. Even along the edges, it started to fill in some of those wrinkles that had formed in the skin of the potato. Because in the hypotonic solution, with just pure water, there are no solutes in there. So water would go into the cells because it's hypertonic in there because of the salt and all the amino acids and those type of things. So water's flowing in to that hypertonic cell environment, filling that central vacuole, pushing the membrane out against the cell wall, and it's nice and turgid is the term that your book uses. All right. So again, with that osmosis, that's probably the trickiest of those. So do some practice. Again, there are with Quizlets and all kind of things online. Make up some scenarios, practice identifying hypo and hypertonic and knowing what would happen to the movement of water. All right, you guys have a great day.